sandwich theorem. Okay, sandwich theorem or rule. It is also called squeeze theorem. Okay, now this is used to find limit of a particular function, limit of a function f of g of x when we have two other functions whose limits are known. Okay, so here to find limit of a function g of x, we are to it is used to find limit of a function g of x. We have two other functions whose limits are already known. Okay, so now consider two functions f of x comma g of x. ठीक है, the same domain, in the same domain. Conditions, these are conditions compulsory. Sandwich theorem conditions. The same domain c and c comma d. I will take the domain c comma d. ठीक है, so let's take f of x. Just example I am showing. This is f of x. So this is c, this is d, domain c comma d. Okay, similarly I will take g of x. G of x is okay, this like this. D. Okay, just to show here, I assume two functions, arbitrary functions. This is g of x and g of f of x. Okay, I will change these functions. Now means the domain should be same here. Okay, this is the first condition. And the second condition, what is the second condition? The second condition is f of x should be less than or equal to g of x. Okay, for all x in the domain c comma d. Okay, c comma d. Our note point, you should note one point here. What is the note point? Note point is f of x comma g of x need not to be continuous in c comma d. ठीक है, f of x and g of x need not to be continuous, they can be discontinuous. For more brief understanding, I will assume discontinuous functions. Okay, so that you will be expert in the subject. Okay, not just mug up the diagrams, you should be expert. Okay, so let me assume f of x as like this. Some बताओ क्या? Okay, let me assume f of x like this. This is C, my domain C. This is D. Okay, and g of x as g of x as, what is g of x? I will take like this. Okay, this continuous function. So it is not continuous at these points. Like this, and this is my domain. This is C. This is D. And the condition is f of x should be less than or equal to g of x. Okay, means here if you combine these both, if you combine these both, let me take g of x. Okay, समझ में आ रहा है? This is g of x and f of x I will take as and the domain is C. D. Okay, this is my domain. They said that f of x, assume f of x is less than or equal to g of x inside this domain. Okay, so you see full red color marks are above g of x. Note, you should also note this point. One more note point. What is the note point? बच्चों बताओ. You should have conceptual clarity. Note that key outside of domain, outside, it is need not to be that f of x should be less than or equal to g of x. Means outside of domain f of x can be greater than g of x. Okay, let's take SIK outside domain. Here this is D, and outside domain let's take f of x is like this. Okay, and g of x is ऐसा आया कहीं नीचे. ठीक है, f of x is greater than g of x. Outside domain we don't care. Sandwich theorem is saying just inside domain. Okay, so we don't care these points, but inside domain f of x should be less than equal to g of x. Okay, now and this is the second condition. Let's go to third condition. Condition third. The third condition is बच्चों बताओ क्या condition is if at x equals to a, any point a, ठीक है, if at x equals to a, limit x tends to, limit x equals to a, limit x tends to a, f of x exists. ठीक है, again limit x tends to a, g of x exists. If at any point x equals to a, if both limits exist, okay, then sandwich theorem is saying that then limit x tends to a, then sandwich theorem is saying that limit x tends to a f of x less than or equal to limit x tends to a g of x, and a is inside the domain C, comma D. Okay, this is the sandwich theorem. Let's show through diagram. Okay, so let's draw the g of x. Let's take, ठीक है, for a brief understanding I am taking this discontinuous position. Okay, again थोड़ा नीचे ड्रा करते हैं. ठीक है, again f of x is like this. It is like step x. Okay, now is it satisfying the first condition? Let's see the domain. Let's take in the domain. This is D. Okay, D, and this is C. Now inside C it is there, and inside C second condition is g of x should be greater than f of x. See, g of x is above f of x in from C to D. Okay, between C and D the g of x is always above than f of x. Okay, so second condition also satisfied. And sandwich theorem says that let's take any point A. Okay, point A, inside domain C and D. This is A. Okay, now sandwich theorem said limit x tends to A, f of x exists, and limit x tends to A, g of x exists. What does it mean exist here? Exist means limit x tends to A minus f of x equals to limit x tends to A plus f of x equals to some value L. It means limit exists. Similarly, limit x tends to A minus g of x equals to limit x tends to A plus g of x equals to some value. Then we can say the limit exists. Okay, limit x tends to A minus, this is A minus h, limit x tends to A plus, this is A plus h. Okay, similarly This value is, what is the corresponding y value at a minus h? Let's take it is k1. And what is the corresponding value at a plus h? This is again same k1. Okay, k1. Similarly, what is the corresponding value at a minus h g of x? When x tends to a minus g of x is it is, let's take k2. Okay. Similarly, what is the value of f of g of limit x tends to g of x at a plus h? This is also k2. Small difference, but it equals to k2, almost equals to. And we don't care whether there is one exception in sandwich theorem. I will also discuss that. We don't know what happens at x equals to a, whether this is continuous or not, whether we can't even, the condition of sandwich theorem, f of x is less than or equal to g of x, it may not satisfy here. At x equals to a, f of x can be greater than g of x. That is one exception in sandwich theorem. Okay, that's why we didn't represent at x equals to a. We don't want, because our interest is limit x tends to a. Our interest is not at x, what happens at x equals to a. We don't want g of x, g of a, or we don't want f of a. We want limit x tends to g of a and limit x tends to f of a. We want that only. Okay. So, sorry, this is y-axis here. This is k1. This is k2. Okay. So, समझ में आ रहा है? Observe diagram carefully. So, if you observe here, what you can observe? Limit x tends to a minus f of x equals to limit h tends to, okay, you can observe here limit x tends to a minus f of x, means limit x tends to a minus f of x, what is the value it is tending? If you observe, it is going to k1. Okay, k1 equals to k1. Okay, similarly, limit x tends to a plus f of x equals to k1. Okay, limit x tends to a plus f of x is tending to k1. Okay, sandwich theorem said that when limit adjusts, what does it mean? This is left hand limit, this is right hand limit. When left hand limit equals to right hand limit, means limit adjust equals to k1. Okay. Similarly, limit x tends to a minus g of x equals to, what we got? Limit x tends to a minus g of x is k2. Limit x tends to a plus g of x equals to k2. Okay, and again, this is left hand limit, this is right hand limit. Okay, so when left hand limit equals to right hand limit, then we can say limit adjacent equals to k2. समझ में आ रहा है? Okay, good. Left hand limit equals to right hand limit equals to k2. What sandwich theorem is saying? So let's erase this diagram. Sandwich theorem said that when both limits, limit x tends to a minus f of x equals to limit x tends to a plus f of x equals to some limit, some k1, limit x tends to a minus g of x equals to limit x tends to a plus g of x equals to k2. When these both limits adjust, means then what he said that limit adjust, we seen limit exist, and he said that limit extends to a f of x means equals to k1 must be less than or equals to limit extends to a g of x, that is k2. Hence he said k1 must be less than or equals to k2. We observed from the diagram k2 is upside and k1 is less than downside. समझ में आ रहा है? Okay. Okay. Now let's take the case of three functions. Okay, involvement of three functions. Now consider three functions f of x comma g of x comma h of x. ठीक है, consider these three functions. Okay, now in the same domain. Okay, in the same domain, this is h of x. Okay, again this is we can take f of x. And now let's take one more function g of x. Okay, this is g of x. Just continues completely. Now here the condition is we should take only domain c comma d particular domain. Okay, c comma d, this is the first condition, and the second condition is f of x less than or equal to g of x less than or equals to h of x in c comma d. This is the second condition. Okay, and the third condition is, okay, if a is such that limit extends to a f of x less than equals to limit extends to a g of x equals to these both limits equals to some value l. समझ में आ रहा है? Any point a is such that if both limits are equal and they are equals to some value l, and we don't know what happens at a. This is the exception sandwich rule. At a x equals to a, this condition may not valid. That is exception. So we don't take any at x equals to a. This point is we don't know where it is. Okay, and what he said, second condition is limit extends to a f of x equals to limit extends to a g of x equals to l. If the both limits are equal at x equals to a, means this is a minus h, this is a plus h. Okay, so limit extends to a minus f of x is, this is l. Similarly, limit extends to a plus f of x, again l. Similarly, limit extends to a minus g of x, that is also l. If we observe just greater than 1, that is l. Similarly, limit x tends to a plus g of x is L. Okay, if the both limits get equal, adjacent equal, then what Sandwich theorem is said, these both limits equal. Okay, then when limit x tends to a f of x equals to limit x tends to a g of x, i.e. equals to L. मतलब they are saying that limit x tends to a minus f of x equals to limit x tends to a plus f of x equals to limit x tends to a minus g of x equals to h of x. Sorry, h of x. H of x. Okay. Equals to limit x tends to a plus h of x equals to some value L. समझ में आ रहा है? When this happens, when the both limits equal, then Sandwich theorem said, then he said that limit x tends to a g of x equals to must be equals to L. समझ में आ रहा है? Good. Okay. Now, so when the limits of other two functions which are easy to find are equal to L, then we can say the middle function limit is also equals to L. Note that ki Sandwich theorem, we use this theorem when we used to find g of x, where g of x limit finding limit of g of x is very complicated or oscillatory, or we don't know where it is going. Then we assume two other functions f of x and h of x, and if it satisfies the condition of Sandwich theorem, f of x is less than equal to g of x is less than equal to h of x, then if these limits are equal at particular point a and equals to L, then we can say that limit x tends to a, the middle function which is complicated to find, is also L. Okay, ठीक है. And okay, note point is I already said. What is the note point? Note point is Sandwich theorem. In Sandwich theorem, we assumed f of x less than equal to g of x less than equals to h of x for all x in the domain C, D, except possibility at A. Possibility at x equals to A. X equals to A. At exactly x equals to A. Okay. At exactly x equals to A, we don't know what happens to f of A, g of A, and h of A. Okay, means we don't know whether f of A less than or equals to h of A, or whether f of A greater than or equal to h of A. We can't say, because we don't have interest to find at x equals to A. We just want to find limit x tends to A and limit x tends to A minus, limit x tends to A plus. We don't want what happens at x equals to A. Okay, means we don't know the first these all things. We don't know whether if f of A less than or equal to g of A less than or equal to h of A. मतलब this is x equals to A, exactly x equals to A. ठीक है, and we don't know whether if f of A is greater than or equals to g of A greater than or equal to h of A. ठीक है, and we don't know whether f of A is greater than or equals to g of A less than or equals to h of A. ठीक है, and we can't even say limit x tends to A g of x equals to g of E. We can't say this also. We can't say even, because we don't know what happens at x equals to A. These are the Values of functions exact at x equals to a means this means function h of x at x equals to a. This means function g of x at x equals to a. This means function f of x at x equals to a. We don't know what happens. Okay. Similarly, we can't say limit x tends to a मतलब g of a equals to limit x tends to, we can't say this also, f of x equals to l. We don't know these all things whether it happens or not. Okay, because our interest is what happens at x tends to a. Okay, so this is our sandwich theorem. Yeah, next let's do some questions. First question is find limit x tends to 0 x square sine 1 by x. Okay, now how will you use sandwich theorem here? How to find this? Okay, so we know that what happened to sine graph in its whole domain. Sine function is always oscillates between -1 and +1, from -infinity to +infinity. Okay, so we can say -1 less than equal to sine 1 by x less than equal to 1. Okay, if you multiply with a positive quantity x square, okay, if you multiply with positive quantity x square, multiply with x square, sine 1 by x, okay. Now in my case, in my assumption, this is f of x, this is h of x. ठीक है, समझ में आ रहा है? In the as per sandwich theorem, what is the condition? F of x less than equal to g of x less than equals to h of x. Means this condition satisfied, then we can use the sandwich theorem here. Okay, because see, at x equal to 0, this is tending to infinity and it is oscillating. We don't know where it is going. Sine or infinity, no one knows what happens. Okay, मतलब this is an oscillatory function, so it is very hard to find. So for finding this, we will use sandwich theorem. So f of x is I taken minus x square sine 1 by x, h of x I taken x square sine 1 by x. Now using sandwich theorem, what we can say? We can find limit x tends to 0 f of x. If the third condition, limits should be equal, individual limits. So we can find left hand limit x tends to 0 minus, sorry, this is minus x square, no? This is plus x square. So limit x tends to 0 minus f of x is minus x square. This is equals to minus of 0 minus limit h tends to 0 minus of 0 minus h whole square. Limit h tends to 0, this is 0. Similarly, right hand limit x tends to 0 plus minus x square equals to limit h tends to 0 minus of 0 plus h whole square. This is again 0. Means left hand limit equals to right hand limit equals to 0. समझ में आ रहा है? So limit x tends to 0, f of x equal to 0. Similarly, let's find for h of x. Limit x tends to 0, h of x equals to, let's find left hand limit x tends to 0 minus h of x equals to limit h tends to 0, h of x is 0 minus h whole square. This is again limit h tends to 0, 0 minus h whole square is 0. Similarly, limit x tends to 0 plus h of x equals to limit h tends to 0. ठीक है, this is 0 plus h whole square, this is again 0, means left hand limit equals to right hand limit equals to 0, means we can say limit x tends to 0, h of x equals to 0. समझ में आ रहा है? Now we can say from sandwich theorem, what is the third condition of sandwich theorem? Limit x tends to 0 if f of x equals to limit x tends to 0 if g of x or the h of x, ठीक है, then 0 equals 0 we got, so satisfied. So then we can write, then we can say limit x tends to 0 g of x equals to the same value L, means we can say limit x tends to 0 g of x. What is the g of x? X square sine 1 by x equals to what is the value of L? 0. समझ में आ रहा है? So this value is 0 using sandwich theorem. So my second question is question number 2. Okay, question number 2 is ठीक है, in the neighborhood of x equal to 0, it is known that 1 minus mod x less than equals to e power x minus 1 by x less than equals to 1 plus mod x. ठीक है, then find ठीक है, limit x tends to 0 e power x minus 1 by x. Okay, this is our question. So now I will assume f of x equals to 1 minus mod x, h of x equals to 1 plus mod x. ठीक है, so then I will try to find using sandwich theorem. Okay, so at x equal 0, let's see whether the condition of sandwich theorem satisfy or not. What is the condition of sandwich theorem? I said limit x tends to 0 f of x should be equals to limit x tends to 0 h of x. Okay, so limit x tends to 0 f of x is 1 minus mod x, left hand limit x tends to 0, h tends to 0, 1 minus mod of left hand limit is limit x tends to 1 minus mod of 0 minus h. Okay, equals to 1. Similarly, right hand limit x tends to 0 1 minus mod x equals to limit h tends to 0 1 minus 0 plus h equals to 1. ठीक है, so left hand limit equals to h, right hand limit equals to 1, implies limit x tends to 0 1 minus mod x is 1. Okay, so similarly, limit x tends to 0 h of x equals to limit x tends to 0 0 minus left hand limit h of x equals to limit h tends to 0, h of x is 1 plus mod x, 1 plus mod of 0 plus h, this is equals to 1. Right hand limit x tends to 0 plus h of x equals to limit h tends to 0 1 plus mod of 0 plus h, this is 0 minus h, this is 1. So left hand limit equals to right hand limit equals to 1. So we can say, what we can say, limit x tends to 0, h of x equals to 1. Okay, so our condition, what is the condition of sandwich theorem? To use sandwich theorem, limit x tends to 0, f of x should be equals to limit x tends to 0, h of x. Okay, then we can say, what we can say, we can say limit x tends to 0, g of x equals to 1, equals to the same limit. Okay, and what is the value we got here? L equals to 1. So we can say limit x tends to 0, g of x is e power x minus 1 by x equals to 1. ठीक है, समझ में आ रहा है? let's go to last question. Our last question is if 0 less than log x, base less than or equals to root x for all x greater than 1, then find the value of limit x tends to infinity log x by x. ठीक है, now okay, now 0 less than or equals to log x base e less than or equal to root x, divide with, I want to divide with a positive quantity. Since limit x tends to infinity means x is positive, so again if you divide with x also, still it will be like this, same symbols, less than or equals to x by 1 by root x. ठीक है, so now I will assume 0 by x is 0 again, 0. Okay, by root x. I will assume f of x equals to 0, g of x equals to log x by x, h of x equals to 1 by root x. ठीक है, I will assume this, and let's see whether it is satisfying sandwich theorem or not. First condition of sandwich theorem satisfied, and second condition of sandwich theorem is limit x tends to infinity f of x equals to limit x tends to infinity, left hand limit is same as x tends to infinity, left hand limit is same as right hand limit is same as infinity only, so no change. So limit x tends to 0 infinity, it is 0 equals to 0. ठीक है, and limit x tends to infinity h of x, what is h of x? 1 by root x, limit x tends to infinity 1 by root x, this is again 0. So we got limit x tends to infinity f of x equals to limit x tends to infinity h of x equals to 0, means our sandwich theorem condition satisfied. So then we can say, from this, if this condition satisfied, both are equal, then we can say limit x tends to infinity g of x equals to the same L, this is L. So we can say limit x tends to infinity g of x is log x by x equals to 0. ठीक है, so let's end up here and we will meet in the next session. ठीक है, thank you.